If the tension field provides the underlying structure of where the energy sea is tight or loose, then the texture field is responsible for explaining the direction in which this sea flows. A simple and intuitive analogy would be comparing it to long hair. You can stretch it tight, which represents the tension, or you can use a comb to direct it in a specific direction, which represents the texture. The universe's energy sea behaves in a similar fashion. In addition to areas that are tight or loose, it also has sections that develop specific directions. Imagine a vast grass field where all the grass blades are pointing in the same direction. There are areas where the texture swirls, like the spirals of a whirlpool, and other places resemble a wheat field leaning the same way, with the wind guiding the motion in one direction. This is the way the textures in the energy sea behave. Some push outward, others spin in circles, and some even follow a uniform direction. Take the electric field, for example. It can be visualized as an expansive pointing texture, where the electric field lines are all oriented outward, as if someone were combing the charged particles in one direction. Or imagine the effect of a blow dryer blowing air outward from a central point, and the texture is forced to move outward. The magnetic field is quite different. It's a series of circular textures surrounding current-carrying conductors or magnets. Think of this like water swirling around a drain, or runners on a track forced to run in a circular pattern. The field lines you commonly see in textbooks or diagrams are drawn as arrows or loops. These diagrams suggest that there are invisible lines or structures suspended in space. However, in reality, these lines don't actually exist in the physical sense. What we are seeing are just visual representations of the flow and direction of the energy sea's textures. In essence, the lines are markers to help us understand where the texture is denser or more focused. In areas where the field lines are closely packed together, the texture is denser, and changing direction requires more energy or effort. This is why we say that the field strength is higher in those regions. If you were to scatter some iron filings or use small compasses in such a field, they would naturally align with the texture, gradually rotating to follow the easiest path. Particles moving through this field don't follow a single, fixed lines but instead behave like leaves floating downstream in a river. Whatever direction the water flows, the leaf will naturally follow. In an electric field, electrons accelerate along the pointing textures, while in a magnetic field, they follow the circular textures and curve along their paths. To understand the full behavior of particles, lights, or even larger objects like planets, we need to consider both the tension field and the texture field. The tension field tells us where the valleys and peaks are in the landscape of the energy sea, while the texture field defines the direction in which things move or bend. These two fields, when combined, give us a comprehensive map of the universe's underlying fabric. They determine the path that particles, light, and other phenomena follow through space-time, ensuring that everything moves along the most efficient and stable route possible. The next time you think about forces, remember that they are not just abstract ideas or invisible lines. What we call forces are simply the manifestation of the real structure of this energy sea. These forces are determined by the textures and tensions within this underlying sea of energy. So when we talk about electric fields, magnetic fields, or gravitational fields, we are simply referring to different aspects of how the sea's energy is arranged and how it shapes the world around us. Tap follow, share it on New Physics, Clear Universe.